So let's continue on this num list problem statement. So first thing is we need to, before we write those functions, we need to be clear how they are used. Okay, so we will have a intuitive visualization of that. So what we will do is we will first we need to think how do we declare that number list of numbers, right? So there are n different ways. You can have a linked list of numbers, and you can have an array of numbers, and maybe there are other ways. You can store it in a tree also. If log n search is your favorite, you can do a balanced tree. But anyway, we are not going there. We are simply keeping it as a array. We are not complicating things. So what we are saying is we have a num list, and we will, in fact, I will just use a different name for that. I will not use num list because that's my kind of module name. So I will maybe call it list1. It's a list of numbers, list1. I may have multiple list. So list1 is a list of numbers, and I will have a hash define max num element. Normally we don't hard code. I will not like to write 100 here, so I will just to bring the code to the little middle, I'm adding some space. So I have this, so this is my list, right? And I will hash define this max num element above. So maybe I can say hash define max num element 200. That's my maximum. Okay, so that's fine. So now we know how to, so the data representation is done, that this is how my data is represented. It's a simple array of integers. I could have kept a linked list. I could have very much done this. So I will maybe write that alternative also, doesn't matter. I could have kept a struct node, and I could have said that this node represents one element of the linked list, and then I have a next pointer. Okay, and that more or less could be this thing, and then I might have declared things like this. I may say, okay, head, a linked list is represented by the head, so head is the pointer to the first such node. So that could have been an option, but we are not going there right now. We are going the array way, and now we need to think how will we implement it. Okay, so maybe I will initialize it. We will look at array initialization, but I would like to say about initialization few things. If I don't initialize it, any local thing which is not initialized is garbage. Okay, so right now if I ask that what is the content, if I print it, it will be garbage because I have not initialized it. Okay, and then I could do this, that max num element is 100, and I could initialize it like 10, 20. Okay, so then question arises, like the question arises that what is the length of this array? Is it 2 or is it 100? So the answer is clear, that if I have specified the dimension that it is 100, it is 100. That doesn't depend on how I initialize it. Okay, so the dimension right now will be 100 only. So then the next question arises that, okay, if the dimension is 100 and I am initializing it with 2 elements, what happens to the remaining 98 elements? Are they garbage? So the fact is that if you initialize an array, the complete array is initialized. So what you can say is remaining 98 elements are 0. So if you initialize part of the array, the remaining part is guaranteed to be set to 0. Okay, so that is how it is. And I will say one more concept, that let's say this max num element was 5 hypothetically. Okay, and I gave more than 5 elements here. Okay, so what happens? So then the answer is that then the answer
Index
is,
out of bounds.
sorry, can you repeat?
Array index out of
Array
bounds.
index out of bounds.
No, array index out of bound doesn't happen here. I will explain this. So when I said that I have 5 elements and I'm giving how many? 6 elements, then basically it will ignore the sixth because the dimension of the array is fixed. I have given it 5, so it remains 5. And if I give more initializer, compiler will ignore those initializers, but it will warn. It will give a warning that excess initializers, the extra ones, are dropped. Okay. So you will find it. I have another video, array initialization. It's there also, and we will come back to it also. But you raised a very nice point. In fact, array bound out of range. So that's a very important thing. So let me write some pseudocode there. Let's say I have this array 5 and I write stuff like this: 30, 40, 60. And I write the code array 5 equal to 999. So this is basically the famous off by one kind of family of errors, where we are at the boundary, we are doing a +1 -1 stuff, because we know that the array index starts from 0 and the array length is 5. So what is the last index I can use? I can use 4, n-1, right? 0 to n-1 both included. That's how my loop operates. So this is a off by one error, and the compiler by default doesn't prohibit you. C allows you to do damage. So compiler will not catch this and it will not refuse to compile. At max, if the compiler somehow is able to detect with -w or maybe, then it can give a warning that uh, uh, just a warning. Otherwise, the greatest friend which we will meet today is Valgrind. There is a dynamic memory analyzer program. Because these bugs are most tricky because they are unpredictable. You never know what will happen. If that extra space was unused by the process, maybe the code may work correctly. And if that extra space is used by the process at the customer side, maybe it crashes at the customer side. So Valgrind, what it does is, Valgrind is a process. It runs your executable under a magnifying glass and it keeps watching every byte and every memory access, and anything goes wrong, it complains right there and then. So that's why when we are coding with arrays, pointers, strings, 2D arrays, 2D pointers, array of pointers, pointer to array, we should never be satisfied that our code is working if the output comes correct. We should be satisfied if the output comes correct, and Valgrind says no memory error. And in fact, Valgrind also checks memory leaks also. It says if you do a malloc and you don't free, it tries to catch that. So off by one is happening here. Off by one is not happening here because we are not accessing a index. We are initializing the array, right? So off by one, the index error is not happening here. Is that okay? Any query? Okay, so anyway, that's okay. So what we will do is we will follow a little bit this approach, that we take a problem statement and when the concept comes, then we pause and look at that concept also. Okay, so I will not like to say that okay, for loop separate and while loop separate. End of the goal of an engineer is never to write a for loop, it is to solve a problem, right? So we will keep that approach to the extent possible. Okay, anyway, so that was like a discussion and understanding of how the array is initialized. So we come back that we are having a number of list of numbers and we want to add it. Maybe what I will do is I will just make it 0. I can initialize it like this, and that's a request to the compiler that please set it all clean to 0. Maybe that's fine. But the point is, when I talk of data representation, then I'm now doing a data structure, right? It is a data structure. I'm creating abstract data structure which is called number list. So can it be represented just by this list of numbers? Possibly not. I need one more. I need num elements. I will just call num lm is equal to maybe 0 initially. Okay, because how do I represent my data structure? If I like to visualize it, let me visualize it. Okay, so let me just go to Google Jamboard. So we are doing a problem statement num list, and my data structure or data representation is that I'm using an array. Fine, but then I need to know how much it is filled, right? It's 100 elements, and maybe my list is empty. It can be empty also. So how do I know this array is empty? One option is I can have a very special marker. Maybe I say that -1 means it is empty, and initially I set everything -1. That's a very inefficient and unintuitive kind of approach, and one may say that -1 is a number, so why are you I mean, why are you hating -1? -1 is a very innocent number, somebody may say. So what we will do is we will have this array, and we will simply have another integer that how much it is filled, n, and that's very elegant, right? So what we will do is we will say that num element. So we will say that these two things together indicate that this is my list of numbers, and the moment you do that, then you will realize that you should not initialize it now. In fact, now if you do a initialization, some reviewer may come that okay, please don't initialize, because if my if my number is saying 0, then any content is okay, doesn't matter. My for loop will always work 0 to n minus 1. So if n is 0, it is like going 0 to -1. That means it doesn't go at all. So that's fine. So if this is my data representation, I will like to not initialize, do not initialize, and the key purpose is performance. Why waste CPU cycles writing some bytes to be 0 if my for loops are anyway never reaching there, because my for loops are bounded by n. My for loops are not bounded by 100, right? So I will be bound by n, and maybe for the sake of the simplicity I will call it n. That will save me typing also. Okay, so and maybe I can call it list also, because right now I'm having only one list, so why create list 1? Never mind. So now we have this, and let's try to so for one more function I will like to print implement is print it, right? Because if I can't see what I have created, how do I know what I have done? Okay, so I will say I will have a function numList print also. Okay, great. Now let's just implement quickly numList add and numList print. Always do minimalistic coding. Minimalistic coding means don't ever do that you write 500 lines and then you compile. Never do that. You write 50 lines and compile it, possibly run it also, test it, and then add more code. So you incrementally add stuff. If you are writing even your linked list or hash table or tree, anything, okay, you are doing some project, small project. If you write even 200 lines of code and you discover, oh, I made this basic mistake, this array of pointers should have been declared this way, or pointer to array should have been this way, but I did it this way, and now I have to change at 10 places because I did the whole thing and then I compiled. So keep compiling, and as soon as you get a what to say, minimal yet runnable executable, run. So my first minimal set is I can add one number and I can print it. In fact, my first set can even be that I print a empty list. That can be my approach also, but I will choose add and print because that's interesting. So we want to now visualize how do I add. So I need to add, so I need to call numList add. I need to pass this. Okay, so I need to say pass. Okay, I have not declared the prototype above, but I am first visualizing what parameters will I pass. Once I visualize that, only then I can declare that prototype, right? I cannot write the numList add function without having a clear visualization that how main is calling it and what exact data is main passing. So I'm starting with main in that sense. So that's why the code is not written as a printer. The code evolves just like a parachuter is coming close to the earth. So he kind of zooms in. Anyway, so numList add, and you can say list, and of course you need to pass the n. Okay, and of course you need to pass what element are you adding. Maybe I'm adding that element 1000. Okay, I'm saying please add 1000 to the list. So if you think carefully about pass by value and pass by if you think carefully about pass by value, this n, you will start getting worried actually about by this n already. Okay, so we will see is it a okay thing to pass it n, but I will code it that I am passing n, and we will see that it doesn't work, and we will see how to fix it also. Okay, but I will initially code it in that wrong manner. So I am doing numList add, and I will call print also. So I will say numList print. I will pass list and n. Those are the two arguments. Okay, so good. So numList print, let me write the prototype. So I need to have list and I need to have n. What is my list? My list is a int array. Okay, that's a int array. So I can say int and I can give a array. I can say max num element if I like. Oh, sorry. I can say max num element if I like, but that day we talked that you can pass it in three manners which are equivalent, which are totally equivalent. You can pass using a pointer syntax, because we discussed array of something or array of int and pointer to int, they are very similar. So or you can pass it like a array with unspecified dimension or with specified dimension. I will prefer this approach. Because this is like representing the reality accurately. It's a array. This is also correct, and when you pass this way, compiler summarily ignores that max num element, because when you pass an array to a function, it's not that the entire array is copied, only the base address is passed. So inside this function, list behaves just like a pointer. If you print the size of list, you will get size of address 4 or 8 bytes typically. So it's better not to give this, because, and the other reason is maybe people, the user code may want to have different kind of list. If it is a list of days of month, maybe my range is 31 only, and if it is a list of maybe weekday, it is 7 only. If it is day of the year, it is 365. So maybe there may be different list of different sizes people may create, and once I have taken n, then always trust n as the better candidate than num elements, because you can understand, you have this yeah, let me, so you have this bigger thing like max some dimension. If you write a for loop for I equal to 0 and I less than max, then you are inviting trouble, because you may be accessing this area, right? So but if you are writing the loop between 0 to n minus 1, then you are very safe, right? So always trust n more than max, because max may be extra space which I'm not using currently. I have only one element in my list, so my loops go from 0 to 0, that's all. They don't go further. So in that sense, we will not like this approach and this approach, and we will write this approach, but the all the approaches are good. So that should be print, and what should print return? It should print return nothing rather, right? Okay, numlist underscore search and numlist underscore delete we are not implementing now, so I need to comment it. One way of commenting is I can have this hash if, which is a preprocessor thing. Hash if means I can write some condition, some compile time computable condition, and I will write this condition that just don't do it. If 0, if 0 means don't enter the if. But this is not runtime if, this is preprocessor hash if. Preprocessor is saying that okay, if this expression is 0, I will not include this code in the for the compiler. I will not even include that code. So we are just kind of commenting it in that way. You could have commented using this also. I mean, you may say that what is the big deal, why can't I do this? So you are right, you can do that, but the problem arises when you have nested things. If you have written some comment here, then you will run into problems. Already you are seeing some stuff. So when you have those things, when you have comments and all that, a very clean way of commenting a block is you put it in hash if 0. So in that sense we will put it in hash if 0, because we need it finally, we don't want to lose it. So I will just put that. Okay, good. So now we need to think of the add. So I will quickly create int list and int n and int lm. That's the element to be added. Okay, always use meaningful names, right? That will be good. And right now maybe I'm saying that I will not return anything, but now let's think. This int n is problematic. This int n is problematic. So what we know is that C is passed by value. When we pass that n, this n, in fact I could name it something else also. I could name it arg also, or whatever, arg-n, but n is possibly the best name here. I will use the same name, but point is this is a separate thing. This arg-n is a copy of n. It's not the reference of n. In C there is no concept of pass by reference. That's only in C++. So this n is a copy, and obviously when I'm doing numlist add, somewhere I will like to increment n. Okay, and then it will not work. I mean, it will not work in the sense that when this function returns, the actual n would not change because I modified a copy. Pass by value means that whatever I pass, a copy of that happens, and I modify that. So I have so first thing is I will not write arg-n, I will write n only. Just to ease my speaking, I had written arg-n so that I can talk of this copy separately from what was passed. So one way is that I can pass a pointer to int. I can say that okay, you are taking n, so you are making a copy that's not working, understood. Take the address of n and using that address modify it. Okay, so when in C, when you want to pass things which you want the code to change, the function to change, and the change should reflect, this is the common approach that okay, you pass pointer to that thing, because now you have given his address, then things will be changed easily. Okay, so that can be one approach. We will, for sake of simplicity, avoid it for this little session. What we will say is that it returns a new integer. It returns the latest n. Okay, that keeps my code very intuitive and simple. I'm saying add and give me the modified n. Okay, Just to keep it simple. Later we will obviously pass by pointer. You can call it like pass by pointer, but fundamentally C is always pass by value, and when you pass a pointer, technically speaking, the pointer is passed by value. Okay, so but it's a fair enough in layman terms to call that approach int star p underscore and call it pass by pointer. It's a fair thing, but I'm keeping it extremely simple. I will just say that. Okay, good. So now what will be the code? We can simply write the code. So what is the code? I mean, so this list is currently, when this function gets invoked, it is filled till 0 to n minus 1. Okay, where will be the next element go? It will go at the nth slot. So I can simply say list n is equal to element, and I will say return n plus 1, because my new thing is new length is plus 1, and I will say that tbd check for overflow handle error. Always when you are coding, think of all options, what can go wrong. When you are adding elements, maybe there are 100 elements already, so ideally I should do a check if n is what to say, if n is less than max num element, or maybe I can say this code like this. I can write a code like this. I can say if n, okay, n is greater than equal to max num element, then we print a error, and we then also different approaches exist. Sometimes for some errors you might want to close the process, exit the process entirely. You may say exit means terminate the process, come out. For some you may want to return. Okay, for some you may want to return. So maybe what I will do for now, I will not like to exit the process, that will be too much. So I will simply print. So maybe I will print, but this is a error print. You remember that std out and std err. So we will write it like to write it on std err. We will say std err list full, maybe a small one like that, and I will just qualify that it's an error. And now I don't want to exit, I want to return, but my thing is that I need to tell the caller code that did I succeed or did I fail. So sometimes you will find paradigm like function returns a true false or success failure kind of output, output in the sense return value. Differentiate between output and return value. So return value is success or like that, but for us we don't have that paradigm. We are returning the new dimension. So what we will say is n, we are returning n. So we are saying it has failed and I am returning n, that not added. What you had is what you have. So whatever you asked to add, I cannot add because I don't have room for it. Okay, so I think this is quite fine, and I can remove this tbd now, but I can keep this check for overflow handle error. It's a very good idea to have small comments indicating, explaining the subsequent block that I'm handling error. Okay, so if n is already full, in fact one may say that why are you checking greater than equal to, why can't you check just equal to? You will be correct in that way also, because the point is that it can never be max num element plus 1. So even that is a good enough thing. Some people like to put the bracket, but some people don't. I personally think adding a bracket is cleaner. Extra brackets don't hurt. So this is numList add and numList print. Let's print it. So let me just say we are doing a for loop, I equal to 0, I, okay, just writing a bit cleanly, less than n, I plus plus, and printf %d. I'll put a space. I'll put the list in one line instead of vertically. Instead of writing every number in a separate line, I will just make it space separated. So I will say list I, and once the entire list is done, I will put a new line, and I will of course print that I will say list colon. So that looks fine. List colon, I will get list of numbers, space separated, and then I put a slash n. Some people, when they are careless, they write like I less than equal to n. So then you happen to access the index n. That's a off by one error. You may not overshoot the valid memory because maybe only 15 elements is there, so you access that index 15. It is still within the valid memory. Valgrind will not say anything, but logically you have violated. Only 0 to 14 was the range. So be careful of these off by one errors. Just be careful. Should it be so if you are writing less than equal to, maybe n minus 1 may be fine, but I think the standard way most people do is less than n. Sorry, less than n. Okay, so this is printing. Let me just quickly make it compilable and runnable. Okay, so I will have stdio.h, and I will do a self review. Ideally you should do it this way, that compiler should not give even a compilation error. Your review should catch it, because if you follow that paradigm, then you will catch the logical bugs also. So let's do a self review. List is int this thing n element. If n is maximum element defined, return n. Looks good. And here I observe that a kind of clean convention space around. Convention also matters. When you write clear code, your brain is also uncluttered. Okay, so don't underestimate the power of a clean code. It will help your thinking. So, and of course I forgot to declare int I here. I can do that. Should I initialize I to 0? Different people have different things to say about it, but I tend to have that thing that if I'm setting it later, why initialize it? Okay, but if you initialize it, no harm done. Small integer. For big arrays, initialization carries a kind of overhead. That's a small one. And then I'm printing it, and then I created it, and I add. So why can't I add a little more? That will be interesting. So let me add 2. And here, when I'm reviewing the code, here I remember that, oh, numList add is returning the new value. So I should catch it, right? I need to write code like n is equal to this. If the same thing appears on the left hand side and right hand side, it's kind of okay, because the right hand side will be computed first and then it is overwritten. But never write code like n plus 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 n plus plus. That code is very good for puzzles but never good for engineering projects. Okay, so in engineering our job is not to puzzle everybody. Our job is to get the problem statement solved. So numList print, and I should so I can use return 0 also here. When from the main, when you return, the process exits. Okay, so some people write return 0, some people write exit 0. All are good. If you are writing exit 0, you will need to include stdlib.h just for avoiding that implicit declaration warning. Return 0 you can do just like that. One thing I remember that, okay, I think it's fair enough, so we can try compiling it if it works. Let's see. Okay, so we have this numList, yeah. Let's compile. We will make it a multi-file also. So we got warning and no error. Okay, numList underscore print. Okay, so print versus add, I think I messed up. So here it is saying return type defaults to int, line number 47. So line number 47, I can say colon 47. Okay, so return type defaults to main. So when we don't give a return type of any function, it defaults to int. Okay, what it is saying is that don't rely on the default, state your intention clear, so rather write int. Okay, don't go for that default understanding. So that I agree. I because I, you remember I wrote the pseudocode there earlier, main, add, search. So then I forgot to expand this here, and the warning is reminding me. So I have done that. Okay, then it is saying implicit declaration of print, and it is saying did you mean add? So we are calling print here, and compilers these days are okay, so compiler thought that this function is defined, maybe that. So basically compilers are more and more, they are able to do static analysis. What is static analysis? It is that some program, either the compiler, or we have splint also, we have lint also, and we have other tools also, they just uh, parse the code, and without running it they see and they think that what could be wrong. So naturally I want print only. So let me see what I missed. Numlist underscore print. Okay, numlist underscore print. So I will maybe search on this element. If you do shift star, it searches on that. It matches also. So maybe the first warning caused it. Let me recompile it. Might just go away. Perhaps not. Okay, now okay, I forgot to say int n. That's the error. Unknown type name n. So basically because numlist print I got a error, so that numlist print was never defined. So now it is saying that I don't know this numlist error, numlist print. So first, obviously, we always look at the first error. Maybe I visually forgot to realize that this is the first error. Okay, int n. So when you are solving errors and you get 100 errors, never be frightened. When you solve the first error, maybe 50 may just disappear. Okay, so because once you make one error, the compiler is now thoroughly confused, like this error. So now compiler thinks this function is not defined, so everything goes confused. So let's see, we okay, it's compiled. So let's run it, and you have added and you got a list with two numbers. So I think we achieved one level of implementation of the data structure. We have represented it well. We have said that my data structure is basically an array and a number. Whatever utility function I create, add, delete, search, this, I will pass these two, and that utility function will do. Okay, now subsequent we will do some search, insert something, and there we will have some loops and switch case and all that we will see. So one level we have done.